Hello everyone, here I am again. So here is to show you today I'm gonna explain the bus bar and all connections I have in the system. So let's start from here. As I explained in previous videos, I have two inverters connected here, one in each. I have the UKK blocks, which comes from the charge controllers, positive and negative. If you wanted to know more, you can see my previous video. And here I have a thermostat. I will explain a bit of why I did that setup. Basically, if you look at the inverters, which are these two, they pull 900 watts at a voltage between 48 volts and 53 volts, which means in practice that is roughly 20 amperes, right? That's why I have here circuit breakers of 32 amperes, which are available on the market. So to protect any short circuit and also to do maintenance when it's needed, right? From the inverters and the charge controllers, which is this circuit of 63 amperes, they are connected to the bus bars. So the bus bars, where I have the battery over here connected, it has, my battery is 48 volts, 100 amperes maximum. But my system, the maximum that is, it's the power here is around 50 amperes peak. Then I have I have a fuse of 100 amperes, and then I have connected here the charge controllers, which they can pull a maximum, they can push a maximum of 50 amperes, right? So that's the peak. And then I have the two inverters connected here, and the maximum that they can pull from the system is 40 amperes, right? So, and on those I have fuse of 40, and on the charge controller I have a fuse of 60 amperes. As I said before, the maximum that I can get here is 50 amperes. One important thing I did is, and you know, the details not everyone explains, is it's very important the order that you place in the bus bar with fuse. So first I have the battery, then I have the charge controllers, and then I have the inverters. In the beginning I had the inverters first, and then the charge controllers was on that side. That was not good and was not working as expected. And mainly because the flow of energy, it comes and it needs to, because this is the charge controller, the energy needs to come and flow. When the inverters are not pulling energy, I need that the energy flows to the battery. And when the inverters are pulling energy, I want the energy goes on that direction and go to the inverters. So that's an important setup. So battery, charge controller, and inverters. Try to make the energy take the most of the whole system. On top of that, I did a mistake in the beginning where I have not noticed, and then I put the washers, the nuts, in the wrong order. Actually, you need to have the lugs connected is be the first part, and then the wash hose, and then the nuts. If you put the wash hose below, it's gonna affect your system, right? That was important point to, you want a very a system that performs very well, right? Here is the negative. There are no fuse, because the positives will protect the system. And here I have the UKK blocks. And the UKK blocks, I have UKK blocks basically because I have two charge controllers. If you see previous videos, I have two charge controllers because I have two arrays. They are turned on the roof to different directions. And then what I do, all energy comes here, enters in the UKK blocks, and from there both comes to the 63 amperes. As I said before, maximum I can get here is 50 amperes. So, and then I have a UKK, you need to leave between 1.25, 1.50, or 50% more or 25% more capacity on the circuit breakers, right? So the cables here, so as here a maximum I can get maximum I can pull from the inverters is 20 amperes. So the cables need to be sized correctly. So the cables I have here is 6 AWG. They can support 50 amperes. So I'm working on half of their capacity. So the maximum temperature I see here is 35, 36 degrees. And as in the main circuit breaker that gets the power from the charge controllers, I have a 6 AWG cable. And that's the reason, is because the maximum I can get here is 50 amperes. And this cable can manage around 93 amperes cable. All these cables, another important thing is the cables are flexible cables, because it's much easier to work and much safer, right? So that's very important. And for last one is the thermostat. As this is in a rack, it's not in an open space, I have a thermostat, which it works from 0 to 72 volts DC, and it's connected to the charge controller, right? And what it does when the rack is above 25 degrees, you have here the way of configure what temperature you have. You can put 20, 25, 30, 40, whatever you want. And then it will turn on the fans automatically. So basically it's fully automated. You don't need to do anything when it's in operations. So all in all, so what happens is, at working in a maximum state, I have 50 amperes coming from the charge controllers, and I have 40 amperes pulling to the inverters, right? When I have this working, it's able to generate about 2000 kilowatts, right? The inverters will pull actually 1800, because they are set, they can handle 1000 each, but I have put the limit there to maximum of 900. And actually the solar panels that I do have can feed completely the inverters, pulling minimum power from the battery, right? So when the system, with this setup, when the system is not generating energy, who is feeding the inverters, is the battery. When there is power production from the solar panels, either goes to inverter or goes to battery. So it's a very efficient system. It's compared with a professional system. It can nowadays is generating over the winter about 150 kilowatts per month, and about 300 over summer. Having in mind that my solar panels here, they are not too much, so I do have there in the roof 6 panels divided in 2 arrays. Each array 3 panels. Each panel has 425 watts, 36 volts roughly, and as they are in series, the maximum I get here is each charge controllers gets 99 volts closed, 110 volts open, and 13 amperes. So very efficient system, working perfectly. So, very important are the connections, how you connect. It's very, very important you in the beginning you see if there is any signs of heating. So I bought a device which can measure the temperature. You can see here now it's a bit cold here, 14 degrees. So it's working in a very good state. You see everything is around 14-15 degrees right now. So, but I have no load right now, and production is very slow, very low. So very efficient DIY system. The production right now, it's comparable with any professional system. So doing the right balancing of power, either to the battery, which is 48 volts, 100 amperes, or to the inverters, which are 1000, they can generate 1000 watts peak continuously actually, and they can get a maximum of their voltage, their working voltage is between 22 volts and 65 volts. So let me know if you have any questions. I'm just showing you to understand what has been done and how I turned the system so efficient, and more people can use and do similar stuff and do your tests. Thank you. Take care. Hope that this give you some insights. Bye bye.